So we're going to be isolating a variable from various volume formulae. So the first one is the formula for the volume of a rectangular prism, which is length times width times height. And that would be if you were given a prism like this, and you've got length, width, and height. But if you don't know one of the measures, length, width, or height, but you do know the volume, you can rearrange that formula in order to solve for the thing you don't know. So the relationship in this formula is multiplicative. It's multiplied together. So to isolate one of the values, like for example, length, I would divide the volume by the width and the height. If I were looking for the height, I would divide that volume by the length and the width. And the last one, if I was looking for the width, I would divide the volume by the length and the height. So those three different equations, 1, 2, and 3, are rearranged versions of the original. They're based on the original formula that you were given. Okay, the second one we're going to look at is for the volume of a cone. In this one, you have two variables. You've got the radius of the base, and you've got the height of the cone. Just defining what these variables mean. So a cone is, of course, circular base and a shape kind of like that. So if I've been given the volume, I can isolate or solve for one of the dimensions in the following way. The first thing I would do, let's say I was looking to isolate h. I would need to multiply the 3. Instead of dividing by 3 on the right, I'm multiplying by 3 on the left. Then I would need to divide away the pi, the value of pi. And I would also need to divide away the value of r squared, whatever that turns out to be. So that's an expression for h. The second possibility, I'm actually just going to move this h over a little bit to make some space, is similarly, start with multiply the 3. That would be then pi r squared h. I'm going to divide that 3v by pi and h. And that gives me an expression that's equivalent to the r squared. And at this point, to undo an r squared, to isolate for r, I'm going to need to square root both sides. The opposite of a square is a square root. So I'm left with r on the right and 3 times the volume divided by pi times h, all square rooted, is the value of r. So we've got two different equations. That come from the original formula for volume of a cone. One of them is isolated for r, and the other one has the height isolated. And that's what algebraic manipulation is.